Hello everyone. Dear students, welcome to our engineering lecture series live session. My name is Aruna, faculty of ACE Engineering College. Today I will explain previous year's questions on first order and first degree differential equations. So this first order and first degree differential equation is the first unit of ordinary differential equations and vector calculus. So first I will explain topics of first order and first degree differential equation. That means I will explain topics in first unit. So topics of first unit are first order and first degree differential equation and applications is our unit name, and first topic is exact differential equations, and second topic is equations reducible to exact. Next, linear differential equations, equations reducible to linear. Next one is Bernoulli's equations. These are the differential equations, and what are the applications? So applications are Newton's law of cooling, law of natural growth and decay, orthogonal trajectories. So these are the topics in unit 1. First, what is a differentiation? So how to define a differentiation? So differentiation is nothing but the rate of change of one variable, the rate of change of a variable with respect to the other variable is called as a differentiation. So that means if we take y is the x and y are the two variables, the rate of change of the variable y, so that means dy with respect to x dx. Here dy by dx is called the differentiation, and in this differentiation the changing variable, here changing variable is y, this changing variable y is called the dependent variable, and with respect to another variable is called the variable x is called the independent variable. Here these two terms are very important, independent variable and dependent variable, to write a solution of a given differential equation. So in this case changing variable is called the dependent variable, and the another variable is called the independent variable. So for example, dy by dx is a differentiation. Here y is called the dependent variable and x is called the independent variable. So this is the definition of differentiation. So how to define a differential equation? So differential equation is nothing but an equation which contains differential coefficients. An equation which contains differential coefficients. In the previous one, in dy by dx, so dy and dx are called the differential coefficients. Okay, so an equation which contains differential coefficients or differentials is called a differential equation. For example, dy by dx minus y equal to 0 is one differential equation, and dou square by dou x square plus dou square by dou y square equal to 0 is another example. And here first differential equation is called the ordinary differential equation, and second differential equation is called the partial differential equation. In first unit we have only first order and first degree ordinary differential equations. Okay, and how to define a solution of a differential equation. So after defining the differential equation, how to find its solution? First of all, what is the solution of a differential equation? In differentiation, dy dx, here y is the dependent variable and x is the independent variable. Solution is depending on these two variables. Solution is nothing but any relation between dependent and independent variable and not containing its derivative. Not containing its derivatives, and that relation must satisfy the given differential equation. So then that relation is called the solution of a differential equation. Suppose if we take y is equal to a cos x plus b sin x. A cos x plus b sin x is the solution of a differential equation d square y by dx square plus y is equal to 0. So here this is a second order differential equation and its relation, its solution. The solution of the given differential equation is y equal to a cos x plus b sin x is the relation between dependent and independent variable. Solution of a differential equation is the relation between dependent and independent variable and that relation not containing their derivatives. Not only that one, and that relation must satisfy the given differential equation, then that relation is called a solution of a differential equation. For example, if we take the relation y is equal to a cos x plus b sin x. So, is the solution of a differential equation d square y by dx square plus y is equal to 0. So, is called this relation y equal to a cos x plus b sin x not containing any derivatives and is the relation between x and y. And observe clearly this relation satisfies the given differential equation. So, we say that this y equal to a cos x plus b sin x is called the solution of a differential equation. Now, here we have two types of solutions. First one is a general solution. So, what is the general solution? Is nothing but a solution in which the number of arbitrary constants is equal to the order of the given differential equation. In previous example, what is the differential equation? D square y by dx square plus y is equal to 0. So, is a second order differential equation and what is its solution? Y is equal to a cos x plus b sin x. Now, here this capital A and capital B are the arbitrary constants. So, how to define a solution? Already we know that this is the solution of this differential equation. When that solution is called a general solution, a solution of a differential equation in which number of arbitrary constant is equal to the order of the given differential equation. So, then such solution is called a general solution. Next, particular solution. So, what is a particular solution? This particular solution of a given differential equation is obtained from the general solution by giving particular values to the arbitrary constant. Suppose here if we give a is equal to 1, b is equal to minus 2. So, then this solution can be written as y is equal to cos x minus 2 sin x. So, this solution is called the particular solution. What is a particular solution? Is nothing but is obtained from the general solution by giving particular values to the arbitrary constant. Such solution is called a particular solution. Next, ordinary differential equation of first order and first degree. So, how to define the first order and first degree ordinary differential equation? A differential equation which contains first order and first degree derivatives, which contains only first order and first degree derivatives of y. Here y is called the dependent variable and known function of x, and x is called the independent variable, is known as first order and first degree differential equation. What is the general form? How to write the general form of a first order and first degree differential equation? So, here we have several forms. One form is f of x comma y comma dy by dx is equal to 0. Here x indicates independent variable, y indicates dependent variable, and here dy by dx is the first order. So, here we have only first order differential coefficient. So, that is why we say that this equation is called the first order and first degree differential equation. We also denote this one as dy by dx is equal to f of x comma y, and also define m of x comma y into dx plus n of x comma y into dy equals 0. Simply we can write this one as m dx plus n dy is equal to 0. So these are some standard forms of first order and first degree differential equations. What is the short answer question from this one? Define first order and first degree differential equation. So this is the definition of first order and first degree differential equation. Our first topic is exact differential equation. How to define? So this is also a short answer question. What is a question from question from this topic is define exact differential equation and give one example. So how to define the exact differential equation? Here not asking necessary condition, just how define exact differential equation. So the solution of it. So any first order differential equation which is obtained by differentiation of its general solution. By differentiation of its general solution without any elimination or reduction of the terms, then such type of differential equation is called the exact differential equation. Suppose if we take a equation x square plus y square is equal to a square. So this is one relation. If we differentiate this equation with respect to 2x, differentiation of x square is 2x plus differentiation of y square is 2y into dy by dx is equal to 0, because a square is the constant, differentiation of constant is 0. If we write this equation into standard form, so what is the standard form? X into dx plus y into dy is equal to 0. So this is the first order and first degree differential equation. Here there is no elimination and there is no reduction. This differential equation is directly obtained by differentiating the given differential equation. So such type of differential equation is called the exact differential equation. So it is very difficult to identify the exact differential equation in manual way. So that's why we have, so here m of x comma y into dx plus n of x comma y into dy is equal to 0 represent an exact differential equation. Which represent an exact differential equation. When this differential equation is called an exact differential equation, so we have one necessary condition. What is that necessary condition? Necessary condition for a differential equation to be an exact differential equation. This is very, very important condition. So what is that condition? Dou m by dou y is equal to dou n by dou x. So if in examination define exact differential equation, don't write this condition. This is the necessary condition for a given differential equation to be exact. So actual definition is this one. This is the definition. So one short answer question from this topic is define exact differential equation and give one example. So this is called, this dou m by dou y equal to dou n by dou x is called the necessary condition for a given differential equation to be an exact differential equation. So if the given differential equation is an exact differential equation, how to write the general solution? So the general solution of m dx plus n dy equal to 0 is this one. Integration of m of x comma y into dx plus terms of n of x comma y not containing x are terms free from x in n into dy is equal to c. So here don't write 0, that is c. Since is a first order and first degree differential equation, its general solution contains one arbitrary constant, that's why here write c. So this is the formula. And one more doubt, here this integration is performed with respect to x but is a function of x and y. Is a function of x and y, but integration is performed with respect to x. That means which indicates here treat y as a constant. Integration is performed with respect to x only. In this case, treat y as a constant. That is the key point to write the general solution of an exact differential equation. So this is the formula to write the solution of a exact differential equation. So here some previous questions are there. So these are the questions. We will solve one by one. Yes, first question. Solve x square plus 2 sin y into dx plus 2x cos y plus y into dy is equal to 0. So what is the standard form of exact differential equation? First compare the given differential equation with the standard form. What is the standard form? So standard form of the given differential equation is m dx plus n dy is equal to 0. So consider given differential equation. If we consider it is equation 1 and equation 1 is of the form m dx plus n dy is equal to 0. Now compare these two forms. So here what is the m? M is equal to x square plus 2 into sin y and n. N is equal to 2x into cos y plus y. And what is the necessary condition for the exact differential equation? Dou m by dou y is equal to dou n by dou x. To check the given differential equation is exact or not, partially differentiate m with respect to y. Here differentiation is performed with respect to y only. Okay, dou m by dou y. So while we differentiate with respect to one variable, treat other variable as a constant. Here differentiation of x square is 0 plus 2 into differentiation of sin y. Differentiation of sin y is equal to cos y. Okay, next differentiate partially n with respect to x. Why we differentiate m with respect to y and n with respect to x? To check the necessary condition of exactness. So what is a dou n by dou x? Dou n by dou x is equal to 2. Differentiation of x. Here differentiation is performed with respect to x only. While we differentiate with respect to treat other variable as a constant. Now here cos y is the constant and differentiation of x is 1. So totally here coefficient is 2 cos y plus here y. But differentiation is performed with respect to x, that is equal to 0. So what is the dou m by dou y is equal to 2 cos y and dou n by dou x is equal to 2 cos y. What is the observation here? From these two equations we can write dou m by dou y is equal to dou n by dou x. If dou m by dou y is equal to dou n by dou x, we can write equation 1 is an exact differential equation. Is an exact differential equation. When it is an exact differential equation, how to write the general solution? We have a formula. So what is the general solution formula? So therefore, general solution of equation 1 is, in examination, you must write the formula for the general solution, then only substitute required terms. Okay, what is the general solution? General solution is integration of m dx plus integral, what is the second one? Terms free from x in n, capital N, into dy is equal to c. This is the formula to write the general solution, and in a given question, what is the m? So m is equal to x square plus 2 sin y. X square plus 2 sin y into dx plus, what is the second one? Terms free from x, n. So here this is the only term which is free from x. So what is the term? That is y. Y into dy is equal to c. And in a first integration, this first integration is performed with respect to x. While we integrate with respect to x, treat y as a constant. So that implies, what is the integration of x square? X cube by 3 plus. Now here 2 sin y is the constant because this integration is performed with respect to x. So 2 sin y, and what is the integration of dx? That is equal to x plus integration of y. What is the integration of y? Y square by 2 is equal to C. So this is the general solution of a given differential equation. So this is the general solution. X cube by 3 plus 2 sin y or 2x into sin y plus y square by 2 is equal to C is the general solution of given differential equation. So this is the first one solution. What are the key points to solve this differential equation? First, compare the given differential equation with the standard form. What is the standard form? M dx plus n dy is equal to 0. Identify m and n. Next, to check the condition for exactness, partially differentiate m with respect to y, partially differentiate n with respect to x, and check the condition. If these two partial derivatives are equal, then the given differential equation is called exact. When it is exact, using this formula, write its general solution. So, to write the general solution, here we need all the integral formulae. So that is the very important. Here integration formulas are very important to write the general solution. If you know all the concept, but without knowledge of integral formula, we are unable to write its solution properly. So these are the key points to write the solution of a given differential equation. Coming to the next question, solve. dy by dx is equal to x minus y cos x by 1 plus sin x. So first write the given differential equation into the standard form. So first consider given equation is 1. And what is our standard form? M dx plus n dy is equal to 0. By cross multiplication of this equation, we can write x minus y cos x into dx by cross multiplying. Okay, minus 1 plus sin x into dy is equal to 0. This is the standard form of the given differential equation, and this equation is of the form m dx plus n dy is equal to 0. So what is our first key point? First write the given differential equation into the standard form. What is our next point? Identify m and n. So here what is the m? X minus y cos x and n minus of. So here we have minus of n is equal to minus of 1 plus sin x. Simply we can write which is equal to minus 1 minus sin x. Next, to check the condition for exactness, partially differentiate m with respect to y and partially differentiate n with respect to x. Now, dou m by dou y. So, here in a partial differentiation, here partial differentiation is performed with respect to y. So, treat x as a constant, differentiation of x is 0 minus differentiation of y is 1, its coefficient is cos x. Differential and integral formulas are very important to solve the any order differential equations. In first unit, all the differential formulas and integral formulas are very important. Okay, so this is what is a dou m by dou y is equal to minus cos x. Similarly, if we differentiate n partially with respect to x, differentiation of here minus 1 is the constant, differentiation of constant is 0. And differentiation of sin x is cos x. Here we have minus sign, that is equal to minus cos x. From these two partial derivative, what is the observation? So both are equal. So therefore, dou m by dou y is equal to dou n by dou x. When dou m by dou y is equal to dou n by dou x, then equation. So if we consider it is equation 2, therefore equation 2 or equation 1 is an exact differential equation. Is an exact differential equation. When it is an exact differential equation, it's a general solution using the following formula. So therefore, general solution of equation 1 or equation 2 is, so first to write the formula. What is the formula? M dx plus integral. So in a second integral, so don't confuse here, terms free from x in n only. Okay, so that is first write the formula. Terms free from x, free from x in n into dy is equal to c. Don't write here 0, that is blunder mistake. So now if we apply the m value, so that is here what is the given m? M is equal to x minus y cos x into dx plus, and in a second term, so that means in n, terms free from x, term free from x is only minus 1, so that is equal to integration of minus dy is equal to c. So here integration, first integration is performed with respect to x, treat y as a constant, integration of x is x square by 2 minus, here y is the constant, integration of cos x is minus, integration of dy is y is equal to c. So which gives a required general solution of a given differential equation. If you know the concept, then it is very easy to write its general solution. This is the second one solution. Dear students, try to solve differential equation simultaneously with me. So please post your answer in chat box also. Try to solve this differential equation. What is the differential equation? Cos x plus y into sin x into dx minus cos x into dy is equal to 0. So first consider the given differential equation is 1 and compare the given differential equation with the standard form. What is our standard form? M dx plus n dy is equal to 0. So now compare the given differential standard form. Here what is the m? M is equal to cos x plus y into sin x and n is equal to minus cos x. So to check the condition for exactness, partially differentiate m with respect to y. So what is a dou m by dou y? So here differentiation is performed with respect to y. So here cos x is the constant. Differentiation of constant is 0 plus differentiation of y is 1. Now here its coefficient is sin x. So dou m by dou y is equal to sin x. Similarly, if we differentiate n with respect to x, so differentiation of minus cos x. So minus differentiation of cos x is a minus sin x, that is totally sin x. What is the observation? Therefore, dou m by dou y is equal to dou n by dou x. When necessary condition exists, then we say that equation 1 is an exact differential equation. Is an exact differential equation. When it is an exact, how to write its general solution? General solution of equation 1 is, please write the formula in examination. So what is the formula? Integration of m dx plus integral terms free from x. Terms free from x in which one? In n into dy is equal to c. So here what are the terms of m? Integration of m. M is equal to cos x plus y into sin x. And observe clearly here first integration is performed with respect to x and treat y as a constant plus terms free from x in n into dy. So there are no terms free from x. So that is 0 into dy is equal to c. Now first integration is performed with respect to x. Integration of cos x is sin x. While integrating with respect to x, treat y is the constant and integration of sin x is minus cos x is equal to c. So that implies what is the general solution? Sin x minus sin x minus y cos x is equal to c. So this is the required general solution of given differential equation. At last, to put your solution in a rectangular box that indicates that is the final answer. So this is the general solution of a given differential equation. Please post your answer in chat box. Next, solve the differential equation. So if we consider equation 1, and equation 1 is n into dy minus m into dx. But what is our standard form? The standard form of the given differential equation is m dx plus n dy is equal to 0. If we compare these two equations here, observe clearly, first term is not m, that is n, and second term is m. So here if we compare these two equations, here what is the m? M is equal to minus x square plus y square minus 1. And what is the n? Is equal to 2xy. So after identifying the m and n, next partially differentiate m with respect to y. What is the dou m by dou y? Here partial differentiation is performed with respect to y. So that's why differentiation of minus x square is 0 plus differentiation of y square is 2y and differentiation of 1 is 0. And if we differentiate n with respect to x, differentiation of x is 1, its coefficient is 2y. So from these two equations, so therefore dou m by dou y is equal to dou n by dou x. When necessary condition exists, so therefore equation 1 is called. So equation 1 is an exact differential equation. If it is an exact differential equation, how to write the solution? So therefore general solution of equation 1 is integral m dx plus integral terms. This is the formula to write the general solution of an exact differential equation. Terms free from x in n into dy is equal to c. So now substitute the given terms. Integral m. What is the m? M is equal to minus x square plus y square minus 1 into dx plus terms free from x n into dy. So there are no terms free from x. So here write that is 0 terms. 0 into dy is equal to c. Now here first integration is performed with respect to x. So what is the integration of x square? X cube by 3. While we integrate, what is the here important key point? While we integrate with respect to 2x, treat y as a constant. So here plus y square into integration of dx is x minus integration of dx is x is equal to c. So rewrite this one, that implies x cube by 3 minus x y square plus x is equal to q. So which is the required general solution of given differential equation. All these are the previous questions, frequently repeated questions. This is the short answer question. What is this question? Verify given one differential equation y into 2x square minus xy plus 1 into dx plus x minus y into dy equal to 0 is an exact or not. So this is the short answer question. So to check the given differential equation is exact or not, first write the given differential equation into the standard form. So if we consider is equation 1, compare equation 1 with the standard form. What is the standard form? Equation 1 is of the form m dx plus n dy is equal to 0. First compare the given differential equation with the standard form. Here identify m and m. M, what is the m? M is equal to y into 2x square minus xy plus 1. If we multiply this total expression with y, so that can be written as 2x square y minus xy square plus y. And what is the n? N is equal to x minus y. So, what is our question? Verify that differential equation is exact or not. Exact differential equation or not. What is our necessary condition? Dou m by dou y is equal to dou n by dou x. That is called the exact. Otherwise, it is called non-exact differential equation. So, to check that condition, first partially differentiate m with respect to y. Dou m by dou y. So, what is a dou m by dou y? Here, differentiation is performed with respect to x. Differentiation of y is 1. Its coefficient is 2x square. Minus, here, x is the constant. Differentiation of y square is 2y. That is 2xy. Next, differentiation of y is 1. And dou n by dou x. Here, differentiation of x is 1. Minus differentiation of y is, here differentiation is performed with respect to x only, treat y as a constant, that is equal to 1. So, dou m by dou y is equal to 2x square minus 2xy plus 1, and dou n by dou x is equal to only 1. So, therefore, how to write? Dou m by dou y is not equal to dou n by dou x. When it is not equal, so therefore, given differential equation is not an exact differential equation. When it is not an exact differential equation, do that formula. So, after changing this non-exact differential equation into exact, then only write the general solution. Otherwise, just write is a not an exact differential equation. What is our question? Is exact or not? So, this is the 2 marks question and short answer question. This is the procedure to check the given differential equation is exact or not. Next. So, this is also a previous question and repeated question. Observe clearly, this is also a repeated question. So, first consider the given differential equation into equation as a equation 1. So, what is our first step? Compare the given equation with the standard form. What is the standard form? M dx plus n dy is equal to 0. Okay. After comparing given equation, write here m and n. Here m is equal to, what is the m? So, observe clearly, this is the m and this is the n. So, please read question carefully. So, this is m dx plus n dy. First term is n. This is of the form n dy plus m dx is equal to 0. So, here what is the m? M is equal to ax plus hy plus g, and n. What is the n? N is equal to hx plus by plus f. For exactness, first differentiate m with respect to y. That is, find dou m by dou y. So, what is a dou m by dou y? Here differentiation is performed with respect to y. This differentiation is 0 plus differentiation of y is 1. Its coefficient is h. Here g is the constant. Differentiation of constant is 0. So, totally dou m by dou y is equal to h. And dou n by dou x. Dou n by dou x. Here differentiation is performed with respect to 2x, x differentiation is 1, its coefficient is h, and here this is the constant 0 and f is also a constant, differentiation of constant is 0, that is equal to h. So, from these two we can write dou m by dou y is equal to dou n by dou x. If dou m by dou y is equal to dou n by dou x, therefore, equation 1 is an exact differential equation. If it is an exact differential equation, how to write the general solution? So, therefore, general solution of equation 1 is, every time in examination, please write this formula when the given differential equation is exact. So what is the formula? M dx, and what is the observation? First integration is performed with respect to x. Here m is a continuous function of x and y. That means treat y as a constant, plus second one is terms free from x in n into dy is equal to c. Now substitute the given values. M, what is the m? M is equal to ax plus hy plus g into dx, plus, here please be careful here to pick up the terms free from x in n. So terms free from x in n, so this is not a term, and by f, these are the terms free from x. So here, which is by plus f into dy is equal to c. Now integrate it. So a into, what is integration of x dx? X square by 2, plus, here integration is performed with respect to x only. That means hy is the constant, integration of dx is x, plus integration of c, here g is the constant, gx, plus here b into integration of y is y square by 2, plus fy is equal to c. So how to write this one? Which is equal to ax square plus by square plus, if we take LCM is to 2h xy plus 2gx plus 2fy is equal to c, which is the required general solution of a given differential equation. So this is the solution of this differential equation. So these are problems on exact differential equation. After checking the condition for exactness, if it is dou m by dou y is equal to dou n by dou x, that means if it is an exact differential equation, this is the formula to write the general solution of a given differential equation. When the differential equation is not an exact differential equation, that is our next topic. Oh sorry, we have one more question. So solve the differential equation. X square minus ay into dx is equal to ax minus y square into dy. So first write the given equation into the standard form. How to write? Rewrite the given equation. X square minus ay into dx minus ax minus y square into dy is equal to 0. So let us consider is equation 1, and this equation 1 is of the form m dx plus n dy is equal to 0. Here what is the m? Compare the m is equal to x square minus ay. Dear students, please try to solve the given differential equation and post your answer in chat box. M equal to x square minus ay and n is equal to, so what is the n? Minus ax plus y square. So to check the condition for exactness, find partial differentiation of m with respect to y. Dou m by dou y is equal to, here differentiation is performed with respect to y. Differentiation of x square is 0 minus differentiation of y is 1. Its coefficient is a, that is minus a. And dou n by dou x is equal to, here differentiation of x is 1. Its coefficient is minus a, and here differentiation is performed with respect to x. Differentiation of y is 0. So that is equal to minus a. So from these two we can write dou m by dou y is equal to dou n by dou x. Dou m by dou y is equal to dou n by dou x. Equation 1 is an exact differential equation. If it is an exact differential equation, how to write its general solution? So general solution of equation 1 is integral m dx plus integral terms. This formula is very important in reducible to exact also. In that case also we use the same formula, but terms are different. Terminology, notations are different, but formula is same. So what is the next one? Terms free from x in n into dy is equal to c. Write the formula carefully. So that implies, what is the general solution? M. What is our M? X square minus ay into dx. That is, first integration is performed with respect to x only and treat y as a constant, plus integral. Terms free from x in n. So here we have two terms. First term contains x. This is the only term that is free from x. So write the term only. Y square into dy is equal to c. Integrate it. First integration is performed with respect to x. Integration of x square is x cube by 3 minus, here integration is performed with respect to x. Ay is the constant, but differentiation of dx is, integration of dx is x, plus integration of y square, that is y cube by 3 is equal to c. So rewrite this equation, x cube plus y cube minus 3axy is equal to 3c or k. This is the required general solution of given differential equation. Please compare your answer with this one and post your answer in chat box. Next topic is non-exact differential equation. So when the given differential equation is called a non-exact differential equation, what is our standard form? A differential equation of the form m dx n dy equal to 0 is said to be non-exact differential equation if in previous we see that one question, check whether the following differential equation is exact or not. In that case we get dou m by dou y is not equal to dou n by dou x. In such cases we say that the given differential equation is not differential equation. What is the condition? Dou m by dou y is not equal to dou n by dou x. If this condition exists, the differential equation, what is the differential equation form? M dx plus n dy equal to 0 is not an exact differential equation. So how to reduce this non-exact differential equation to exact? That is our next topic, equations reducible to exact differential equation. So when the given differential equation is not an exact differential equation, we can change. So we can change that, we can convert that non-exact differential equation into exact by multiplying with a suitable function or factor. So multiply the equation with a suitable function or factor and change the differential equation into exact. Here that multiplied term or factor or function is called the integrating factor. So what is the short answer question from this one is define an integrating factor. This is the short answer question. So in a proper way, how to define integrating factor? So that means, and here one more key point is there may exist more than one integrator. Suppose if we take the example y dx minus x dy is equal to 0. So here what is the m? M is equal to y, n is equal to minus x. What is the dou m by dou y? Dou m by dou y is equal to 1, dou n by dou x is equal to minus 1. So from these two, what is the condition? Dou m by dou y is not equal to dou n by dou x. When this is not equal, so then this differential equation is called equation. How to reduce that non-exact differential equation into exact? By multiplying with a suitable function or factor. Suppose here I am dividing this entire equation with x square. So if we dividing with x square, so that is, if we dividing with x square, so y dx minus x dy by x square is equal to 0. So first divide term by term. So that is y by x square into dx minus x by x square is nothing but 1 by x into dy equal to 0. Dividing with x square or multiplying with square. If we multiplying with 1 by x square, so the differential equation becomes, we get a new differential equation is of the form y by x square into dx minus 1 by x into dy equals 0. Again check the condition. Suppose if we compare the given differential equation with m1 into dx plus n1 into dy equal to 0, because is a new differential equation, this becomes so again check that is exact or not. This new differential equation is exact differential equation or not. Here what is a m1? m1 is equal to y by x square. So what is a dou m1 by dou y? So here partial differentiation performed with respect to y, differentiation of y is 1, its coefficient is 1 by x square. And what is a n1? n1 is equal to minus 1 by x. And what is a dou n1 by dou x? Dou n1 by dou x. Differentiation of minus, differentiation of 1 by x is minus 1 x square. Minus into minus plus 1 by x square. So observe clearly, dou m1 by dou y is equal to dou n1 by dou x. That means this new differential equation exact. When it is an exact, when we say that this new differential equation is an exact differential equation, by multiplying the given differential equation with 1 by x square. Here that factor or function 1 by x square is called an integrating factor. So that is the example of integrating factor. And how to define integrating factor? So short answer question from integrating factor is define an integrating factor, give a suitable example. And here what is the one more key point? There may exist more than one integrating factor. In the previous example, one y square is also an integrating factor. Not only one integrating factor, there may exist more than one integrating factor. This is a very important key point. So in examination, how to define the integrating factor? So what is the purpose of integrating factor? Using this integrating factor, we can change a non-exact differential equation into exact differential equation. So that is, let m dx plus n dy equal to 0 is not an exact differential equation, and if m dx plus n dy equal to 0 be made exact by multiplying with a suitable function. So by multiplying with a suitable function, here notation is u of x comma y is not equal to 0. So by multiplying with a non-zero function, u of x comma y not equal to 0 is nothing but a non-zero function. Then that non-zero function is called an integrating factor of given differential equation. So previous example is the right example, y dx minus x dy equal to 0. This is the general definition of integrating factor, and this is the short answer question. Here we have some methods to find the integrating factor. So what is the integrating factor purpose? Multiply the non-exact differential equation with that integrating factor, we get an exact differential equation, we get a new differential equation which is an exact differential equation. So here we have several methods to find the integrating factor. So first method 1 is integrating factor of a homogeneous equation. What is the homogeneous differential equation? A differential equation dy by dx is equal to f of x comma y. This is also one standard form of first order and first degree differential equation. A differential equation dy by dx equal to f of x comma y is called homogeneous differential equation if f of x comma y is a homogeneous function of degree 1. So what is a homogeneous function? A function f of x comma y is called homogeneous function if f of kx comma ky is equal to k to the power n into f of x comma y. So in this case we say that this is called the homogeneous function of degree n. When degree is 1, then the differential equation is called homogeneous differential equation. This is also one important key point to identify the nature of the given differential equation. So what is the first method? If integrating factor of equation. So what is the method? If m dx plus n dy equal to 0 be a homogeneous equation in x and y. When we go for integrating factor, when it is non-exact differential equation. So what is the default condition? Here given differential equation is non-exact differential equation and is homogeneous differential equation. Non-exact and is homogeneous differential equation, then 1 by mx plus ny is an integrating factor of m dx plus n dy equal to 0. So these are the reduction methods to find the integrating factor. This is one method when the given differential equation is non-exact and is homogeneous. What is the key point here? And is homogeneous differential equation. This formula is applicable only for homogeneous differential equations, not for all. So if the given differential equation is non-exact and is homogeneous, then 1 by mx plus ny is an integrating factor, provided this denominator is non-zero. Mx plus ny is not equal to 0. If it is equal to 0, integrating factor does not exist. This is method 1. So what is the method 1? Again, if the given differential equation is non-exact and is homogeneous, then what is the integrating factor? 1 by mx plus ny is an integrating factor. Method 2. Integrating factor for an equation of the type. So here we have one standard form. What is the standard form? Function of xy into y dx plus function of xy into x dy equal to 0. Here observe clearly, is not a function of x comma y, is a function of xy. So how to write f of x comma y? F of x comma y is equal to x square plus y square plus 1. We say that this is called the function of x, is not equal to function of xy. So how to define function of xy? Function of xy is equal to 1 plus xy whole square plus xy whole cube in this form. So these forms are called the function of xy. In between x and y there exists an ordinary multiplication. So here what is the standard form? Function of xy into y dx plus function of xy into x dy is equal to 0. So in this case, how to find out the integrating factor is? Then the integrating factor is 1 by mx minus ny. When we write 1 by mx ny is an integrating factor of a given differential equation, if the given differential equation is non-exact differential equation and is of the form y into function of xy into dx plus x into function of xy into dy equal to 0. So this is the nature of the given differential equation. If the given differential equation is in this form and is non-exact, then what is the integrating factor? 1 by mx minus ny is an integrating factor of given differential equation, provided mx minus ny is not equal to 0. When it is equal to 0, integrating factor does not exist. Yes. Coming to the third method. If the given differential equation is not an exact differential equation and is not a homogeneous differential equation and is not in the form of y into function of xy into dx and x into function of xy into dy is equal to 0. In this case, we apply method 3. Here we have two cases. What is the first case? There exists a continuous single variable function f of x. If there exists a single variable function f of x such that which is satisfying the condition 1 by n into dou m by dou y minus dou n by dou x. F of x equal to 1 by n into dou m by dou y minus dou n by dou x. So, if this function exists, how to write the integrating factor? Then integrating factor is e power integral f of x into dx is an integrating factor of the given differential equation. So, here what is the key point? Identify the nature of the given differential equation when it is not an exact differential equation. So, this is the first case. If this case fails, so what is the second case? There exists a continuous single variable function y. Notation is g of y such that which is satisfying the condition 1 by m into dou n by dou x minus dou m by dou y. So, if we calculate this factor, if we simplify this one, if we get a single variable function in terms of y only, so then what is the integrating factor? E power integral g of y into dy is an integrating factor of m dx plus n dy equal to 0. When we apply this method, if the given differential equation is not an homogeneous equation and not in the form of y into function of xy into dx plus x into function of xy into dy equal to 0, and then apply this third method one by one. So, if first case fails, then apply the second case. Next, coming to the fourth method, integrating factor found by inspection. So, sometimes we regroup the terms. So, in several cases, the integrating factor can be found after regrouping the terms. How to regroup the terms? So, terms of the equation and recognizing each group as being a part of an exact differential. So, if you are able to regroup the terms of the given differential equation, this is the easy method to write the general solution directly. Okay, otherwise apply the previous methods. So, these are the previous year's questions. Some questions. Please try to find the solution of a given differential equation, and here when the given differential equation is not an exact differential equation, here identify the nature of the given differential equation is very important. Coming to the first question, so here all these are the non-exact differential equations, and so see this one here, what is the degree of this term is 3 and what is the degree of this term is 3, degree of the next 3, degree of the term is 3. In a given differential equation, degree of each term is same. Such a type of differential equation is called the homogeneous differential equation. So, first one is homogeneous differential equation. Second one is, so here what is the degree? 2. Degree 2. Degree 2. Here degree is 0. So, therefore, is not a homogeneous and not in the second form also. So, I will explain one by one. Yes, first question. Solve x square y minus 2x y square into dx minus of x cube minus 3x square y into dy equal to 0. So, this is the pattern of the question. So, first check that is exact or non-exact differential equation. Consider is equation 1, and what is the standard form of the given differential of the form m dx plus n dy is equal to 0. So, compare the terms here. What is the m? M is equal to x square y minus 2x y square, and n, what is the n? N is equal to minus x cube plus 3x square y. These are the terms. To check the condition for exactness, we have one necessary condition. What is that condition? Dou m by dou y is equal to dou n by dou x. Then it is exact. Check that. Is exact or non-exact? So first to find out dou m by dou y. So what is the dou m by dou y here? Differentiation of y is 1. Its coefficient is x square. Minus differentiation of y square is 2y, its coefficient is 2x, totally we get that is equal to 4xy. Next, differentiate n partially with respect to x. What is that? Dou n by dou x. Differentiation of x cube is 3x square, here we have minus, that is minus 3x square, plus differentiation of x square is 2x, 2 3 is 6xy. So from these two, what is the conclusion? So therefore, dou m by dou y is not equal to dou n by dou x. When dou m by dou y is not equal to dou n by dou x, then equation 1 is not an exact differential equation. Is not an exact differential equation. And how to change this non-exact differential equation into exact? Using the integrating factor. So to find the integrating factor, first identify the nature of the given differential equation. Is not an exact differential equation, and terms, degree of the each term is same. So therefore, this differential equation is homogeneous. So equation 1 is not an exact differential equation and is homogeneous. And is homogeneous. If it is not an exact differential homogeneous, what is our first method? So then what is integrating factor? So then 1 by mx plus ny is an integrating factor. An integrating factor. So next to find the integrating factor. So to find the integrating factor, first to find out the term mx plus ny is equal to m. What is our given m? M is equal to x square y minus 2xy square into x plus n. So terms of n are minus x cube plus 3x square y into y. Simplify this one, which is equal to multiply this one with x into x square, x cube y minus 2x square y square minus multiply this expression with y minus x cube y plus 3x square y square. Now here observe clearly, minus x cube y plus x cube y get cancelled and minus 2x square y square plus 3x square y square, which gives y square x square and is not equal to 0. So when it is not equal to 0, what is integrating factor? So therefore integrating factor is equal to 1 by mx plus ny is equal to, what is mx plus ny? X square y square. So the integrating factor of the given differential equation is 1 by x square y square. After finding the integrating step, so what is the integrating factor purpose? If we multiply the given differential equation with this integrating factor, then we get an exact differential equation. So what is our next step? Multiply the given differential equation with 1 by x square y square. So if we multiply the given differential equation, now multiply equation 1 with 1 by x square y square or dividing with x square y square. So then we get a new differential equation. So what is that new differential equation? First multiply 1 by x square y square into x square y minus 2xy square into dx minus 1 by x square y square into x cube minus 3x square y into dy is equal to 0. So before going to write the general solution, first to divide term by term. So how to write this differential equation? So if we simplify x square get cancelled. First term is 1 by y minus 2 by x into dx minus, again divide term by term, so then we get x by y square minus 3 by y into dy is equal to 0. So let us consider is equation 2, and equation 2 is a new differential equation which is obtained after multiplying with a integrating factor. So compare the new differential equation with the form m1 into dx plus n1 into dy is equal to 0. Here what is the m1? m1 is equal to 1 by y minus 2 by x n1. n1 is equal to minus x by y square plus 3 by y. So that new differential equation is exact or not. So to check that condition, find dou m1 by dou y. So what is the dou m1 by dou y? Differentiation of 1 by y is equal to minus 1 by y square. Here there is no y term, it is a constant, differentiation of constant is 0. And dou n1 by dou x, differentiation. So here minus 1 by y square is the coefficient and differentiation of x is 1, which is also minus 1 by y square. So therefore equation 2 is an exact differential equation. If it is an exact differential equation, we know that how to write the general solution for an exact differential equation. So what is the formula? So therefore general solution is integral. How to write here? Write the general solution for new differential equation. So that's why change the terms also. m1 into dx plus integral terms free from x in n1 into dy is equal to c. Write the formula using the new differential equation, and so that implies integral. What are the terms of m1 here? Terms of m1 are 1 by y minus 2 by x into dx plus terms free from x in n1. So here there is a x term and this is the only term which is free from x, so that is equal to 3 by y into dy is equal to c. While we integrating with respect to x, treat y as a constant. Here 1 by y is the constant. Integration of dx is x minus 2 into, what is integration of 1 by x? Log x plus 3 into, here integration is performed with respect to 2y. What is integration of 1 by y? Log y is equal to c. Rewrite this equation. That implies x by y minus log of x square plus log of y cube is equal to c. So using these two terms, so how to write? X by y plus log of y cube by x square is equal to c. So which is the required general solution of a given differential equation. So this is the procedure when a given differential equation is not an exact differential equation. So when it is not an exact differential equation, here what is the important key point? Identify the nature of the non-exact differential equation. So this is the procedure to find the general solution of a given non-exact differential equation. Coming to the second question. So first consider is equation 1. So in examination they simply given that solve the differential equation. We don't know is exact or non-exact differential equation. So first to check the condition for exactness. If it is an exact, directly we can write the general solution using the known formula. If it is a non-exact differential equation, find the integrating factor using the several methods. So first given equation is of the form m dx plus n dy is equal to 0. So compare the given equation with the standard form. Here what is the m? M is equal to 2xy. and n. N is equal to minus x square plus y square minus 1. So first to check that is exact or non-exact differential equation. So partially differentiate m with respect to y, dou m by dou y. So here differentiation of y is 1, its coefficient is 2x, and partially differentiate n with respect to x. Differentiation of minus x square is minus 2x, differentiation of y square is 0, differentiation of 1 is 0, totally we get minus 2x. So what is the observation here? So therefore, dou m by dou y is not equal to dou n by dou x. When dou m by dou y is not equal to dou n by dou x, equation 1 is not an exact differential equation. Not an exact differential equation. When it is not an exact differential equation, now here identify the nature of the given differential equation. Now here, what is the degree of this term? 2. Degree of this term? 2. Degree of this term? 2. But degree of this term is 0. Means it is not a homogeneous. Eliminate method 1. And coming to the second form. What is the second form of the standard form of the second method? So that is y into function of xy into dx plus x into function of xy into dy is equal to 0. So that is the second method standard form, but the given differential equation is not in that form also. So eliminate second method also. Coming to the third method. So in a third method, what is the case 1? So there exists a single variable function. So first calculate. Consider 1 by n. 1 by n into dou m by dou y minus dou n by dou x. So first consider this factor. So which is equal to n. What is the n? 1 by minus x square minus y square, plus y square minus 1 into dou m by dou y. So what is the dou m by dou y? Dou m by dou y is equal to 2x, and dou n by dou x is equal to minus 2x. So minus into minus plus 2x. So which is not a function of x. Which is not a function of x. That means case 1 is failed. So next, also consider 1 by m into dou n by dou x minus dou m by dou y is equal to 1 by m. What is the m? M is equal to 2xy into dou n by dou x. Dou n by dou x is equal to minus 2x minus dou m by dou y is also 2x. So which is equal to minus 2x minus 2x minus 4x by 2xy. So x get cancelled, 2 1s are 2 2s are, that is equal to minus 2 by y is a single variable function g of y. Let us consider that is g of y. So first case fail and second case is exist. So if there exists a single variable function g of y, then what is the integrating factor? Then integrating factor is e to the power integral g of y into dy, which is equal to e power integral. What is the g of y? G of y is equal to minus 2 by y into dy is equal to e power minus 2 into, what is the integration of 1 by y? Log y is equal to, here we can write which is equal to log of y to the power minus 2. So totally we get right, this is equal to 1 by y squared. So what is the integrating factor of the given differential equation is 1 by y squared. Sometimes they just ask that only find the integrating factor of the given differential equation. Not solving, just find the integrating factor of the given differential equation which makes a non-exact differential equation to exact. This is the procedure, and here what is the integrating factor? 1 by y square. After finding the integrating factor, what is the procedure? Multiply the given differential equation with that integrating factor. So next, multiply the given differential equation with 1 by y square. Multiply equation 1 with 1 by y square. So if you multiply the given differential equation with 1 by y square, so we get 1 by y square into 2xy into dy minus 1 by y square into x square minus y square plus 1 into dx is equal to 0. Before going to write the general solution, first divide term by term. So how to write this differential equation, which is equal to 2x by y. Here 1 y get cancelled, that is equal to 2x by y into dy minus next x square by y square minus 1 plus 1 by y square into dx is equal to 0. So now here which is of the form m1 into dx plus n1 into dy is equal to 0, where what is the m1? m1 is equal to minus x square by y square minus 1 plus 1 by y square. Sorry, this is dx, this is dy. So while solving the question, so if it is wrong, don't cut in this form. Don't cut like this. Okay, so just round up that wrong step like this and put a mark, just cross, but don't cut in this form. Sorry, this is dx, dy, dx, dy. Here m1. So m1 is equal to 2x by y and n1. n1 is equal to minus x square by y square. So next, to check this new differential equation is exact or not, partially differentiate m1 with respect to 2y. Here 2x is the constant. Differentiation of 1 by y is minus 1 by y square. So that is equal to minus 2x by y square. And coming to the n1. So partially differentiate n1 with respect to x. Now here minus 1 by y square is the constant. Differentiation of x square is 2x. So that is equal to minus 2x by y square. So from these two conditions we say that dou m1 by dou y is equal to dou n1 by dou x. When dou m1 by dou y is equal to dou n1 by dou x, this new differential equation is an exact differential equation. When it is an exact differential equation, how to write the general solution? So general solution is integral m1 into dx plus integral n1 into dy is equal to, see here what are the terms? Terms free from x in n1 into dy. So that implies integration of, what is the m1? m1 is equal to 2x by y into dx plus integral terms of n1 free from, terms of n1 free from x. So what are the terms of n1? So here which is equal to, this is the minus 1 plus 1 by y square. So minus 1 plus 1 by y square are the terms free from x. So here integrate it. 2 by y into integration of x is x square by 2 minus integration of dy is y, integration of 1 by y square is minus 1 by y is equal to c. Now if we cancel 2, so that implies x square by y minus y minus 1 by y is equal to c. If we take the LCM, x square minus y square minus 1 equal to cy, which is the required general solution of a given differential equation. This procedure to find the general solution of a non-exact differential equation. Next question, solve y dx minus x dy is equal to a into x square plus y square into dx. So here no need to check the condition for exactness. Clearly we say that here we can regroup the terms of the given differential equation. So how to regroup the terms of the given differential equation? Recognize the each group as a exact differential. So how to regroup the terms? So if we divide entire differential equation with x square plus y square. So if we divide entire differential equation with x square plus y square, right side term is exact differential equation and left side term. So there also exists one exact differential coefficient formula. So how to write? So if we dividing with x square plus y square, y dx minus x dy by x square plus y square is equal to a into dx. And we have one formula, y dx minus x dy by x square plus y square can be written as tan inverse of x by y. So how to see here? What is the differentiation of tan inverse? Differentiation of tan inverse. So differentiation of tan inverse of x by y is equal to 1 by 1 plus x square by y square, again differentiation of x by y. So and how to write the differentiation of x square? So here if we take the LCM, which is equal to y square by x square plus y square, and differentiation of x by y, y dx minus x dy by y square. Now here if we cancel y square and y square, that is y dx minus x dy by x square plus y square. That means y dx minus x dy by x square plus y square can be written as exact differential coefficient of differentiation of tan inverse of x by y. So we can write this one as differentiation of tan inverse of x by y is equal to a into dx. Here all the terms are exact differential. Now apply the integration on both sides. Integration of differentiation of tan inverse of x by y is equal to a into integration of dx plus integral constant is c. And here differentiation integration get cancelled. So that is tan inverse of x by y is equal to ax plus c is the required solution of a given differential equation. If you are able to regroup the terms of a given differential equation such that each group has exact differential coefficient, then this method by inspection is very easy to write the solution. Next question, solve 3xy square minus y cube into dx plus 2x square y plus xy square into dy equal to 0. Consider the given differential equation is 1. So, and compare the given differential equation with m dx plus n dy is equal to 0. Here, what is a m? M is equal to 3xy square minus y cube, and n is equal to 2x square y plus xy square. So first check that given differential equation is exact or non-exact. What is the question form? Just they simply given that solve the differential equation, not solve non-exact differential equation. So before going to find the integrating factor, first first compare the given statement, given differential equation with the standard form, and first check that is exact or non-exact differential equation. So first check that dou m by dou y. What is that dou m by dou y? Differentiation of y square is 2y. So here 6xy minus 3y square. And what is the dou n by dou x? Dou n by dou x is equal to differentiation of x square is 2x, that is 4xy plus y square. So what is the observation here? From these two, what is the conclusion? Dou m by dou y is not equal to dou n by dou x. When dou m by dou y is not equal to dou n by dou x, we can write equation 1 is not an exact differential equation. Not an exact. When it is not an exact differential equation, identify the nature of the given differential equation. So observe method wise. So what is the degree of the term? 3. Degree of the term? 3. Degree of this term is 3. Degree of this term is 3. That means degree of each term of the given differential equation is same. So then such type of differential equation is called homogeneous and is homogeneous. So if it is homogeneous, what is the integrating factor? Then 1 by mx plus ny is an integrating factor. So first to convert the non-exact differential equation into exact, first to find out the integrating factor. So that's why consider mx plus ny. M. What is the given m? 3xy square minus y cube into x plus n. N is equal to 2x square y plus xy square into y, which is equal to, multiply this first expression with x, we get 3x square y square minus xy cube plus, next multiply the second expression with y, that is 2x square y square plus xy cube. Here minus xy cube plus xy cube get cancelled. What are the remaining terms? 3x square y square plus 2x square y square, that is equal to 5. So that is equal to 5x square y square and is not equal to 0. So now what is the integrating factor? 5x square y square is an integrating factor. What is the next procedure? After finding the integrating factor, multiply the given differential equation with this integrating factor, we get a new differential equation which is an exact differential equation. So multiply the given differential equation with, multiply equation 1. So this is mx plus ny, and what is the integrating factor? So therefore integrating factor is 1 by mx plus ny. So what is the integrating factor? 1 by 5x square y square is an integrating factor. So next multiply equation 1 with 1 by 5x square y square. So then we get 1 by 5x square y square into 3xy square minus y cube into dx plus 1 by 5x square y square into 2x square y plus xy square into dy is equal to 0. After multiplying the given differential equation with this integrating factor, we get an exact differential equation, and that is a new differential equation. That new differential equation is an exact. So first divide term by term. So that is equal to 3 by 5x minus 5 by 5x square into dx plus, coming to the second one, that is equal to 2 by 5y plus 1 by 5x into dy is equal to 0. Consider is equation 2, and this equation 2 is a new differential equation which is an exact differential equation. When it is an exact differential equation, how to write the general solution? General solution is integration of. So, and what is this new differential equation form? This is of the form m1 into dx plus n1 into dy is equal to 0. Here, so how to write the general solution? m1 into dx plus integral terms free from x. Terms free from x in n into dy is equal to c. So that is here. What is the m1? m1 is equal to 3 by 5x minus y by x plus next integral terms free from x in n1. So we have only one term, that is 2 by 5y. So 2 by 5y into dy is equal to c. So integrate this one, which is 3 by 5 into integration of 1 by x is log x, while we integrate with respect to x, treat y as a constant, y by 5, integration of 1 by x square minus 1 by x plus 2 by 5 into integration of 1 by y, log y is equal to c. So if we take the LCM, here 5 is 1 by 5 is common, so write first term as log x cube minus into minus plus y by x plus log y square is equal to c. Rewrite this one. So here from these two terms, log a plus log b, so that is log ab, x cube into y square plus y by x is equal to c is the required general solution of a given differential equation. Here no need to write phi c. We can write phi c is equal to another constant k also. So this is the solution of a given differential equation. This is a short answer question. Find an integrating factor which makes the differential equation x square y dx minus of x cube plus y cube into dy equal to 0. This is the repeated question. So just what is the question? This is the short answer question. Read the question carefully. Just to find the integrating given differential equation. So to find the integrating, when we find the integrating factor, if the given differential equation is not an exact differential equation. If it is a short answer question, no need to check the condition for exactness. Okay. So just finding the integrating factor means the given differential equation is not an exact differential equation. Is not an exact differential equation, identify the nature. So clearly equation 1 is not an exact differential equation. If it is not an exact differential equation, to find the integrating factor, identify the nature of the given differential equation. So what is our first method? Homogeneous. What is the degree? 3. Degree 3. Degree 3. That means each term of the given differential equation has the same degree, therefore it is homogeneous. Is not an exact differential equation and is homogeneous. And is homogeneous. If it is an homogeneous, what is the integrating factor? So therefore integrating factor is equal to 1 by mx plus ny. So that is equal to, so now mx plus ny. First find this one, mx plus ny. What is the m here? M is x square y into x minus of n, x cube plus y cube into y, mx plus ny, but here we have minus, that's why here write minus. So this is equal to x cube y minus x cube y minus y power 4, y cube into y power 4 plus x cube y minus x cube y get cancelled. What is the remaining term? minus y power 4 which is not equal to 0. So therefore what is the integrating factor? Integrating factor is 1 by minus 1 by y power 4 is the integrating factor of the given differential equation. This is the procedure for short answer questions. Here no need to check the condition for exactness. Next question. Solve y plus y square into dx plus xy into dy equal to 0. When the type of the question is in this form, here first to check the condition for exactness. So first to consider is equation 1, and equation 1 is of the form. What is the standard form? M dx plus n dy is equal to 0. If we compare these two, here what is the m? M is equal to y plus y square, and n is equal to xy. So to check the condition for exactness, first differentiate m with respect to y. So now dou m by dou y. So differentiation of y is 1 plus differentiation of y square is 2y. Here differentiation is performed with respect to y. And what is the dou n by dou x? Dou n by dou x is equal to differentiation of x is 1 and differentiation of, sorry, its coefficient is y. So dou n by dou x is equal to y. From these two we can write dou m by dou y is not equal to dou n by dou x. When dou m by dou y is not equal to dou n by dou x, equation 1 can be written as equation 1 is not an exact differential equation. What is our next step? When it is not an exact differential equation, here find the integrating factor. So to find the integrating factor, identify the nature of the given differential equation. So what is the degree of the term? 1. Degree of the term? 2. Here degree of the term? 2. So each degree of each term is not same. So is not a homogeneous. Eliminate first method. And is not in the second form also. What is the second form? Y into function of xy into dx plus x into function of xy into dy is equal to 0. The given differential equation is not in the second standard form. And coming to the third method. So if it is not an homogeneous, not in the second standard form, so go to the third method. In the third method, first consider the factor. What is the factor? Case 1. What is the factor? 1 by n into dou m by dou y minus dou n by dou x, which is equal to, what is the n? Is 1 by xy into dou m by dou y. Dou m by dou y is equal to 1 plus 2y minus dou n by dou x is equal to y. So which is equal to 1 by xy into 1 plus y is not equal to f of x. That means in a third method, case 1 fails. Again consider 1 by m into dou n by dou x minus dou m by dou y is equal to m. What is the m? 1 by, if we take y is common, that is equal to 1 plus y into dou n by dou x. Dou n by dou x is y minus dou m by dou y is 1 minus 2y. So if we simplify this one, which is equal to 1 by y into 1 plus y into, so minus 1 minus y. If we take minus is common from the numerator, that is equal to minus of 1 plus y by y into 1 plus y. So if we cancel 1 plus y, minus 1 by y, which is the function of y only. So which is a function of y. When it is a function of y, then what is the integrating factor? Therefore, integrating factor is e to the power integral g of y into dy. So is equal to e power integral. What is the g of y? Minus 1 by y into dy is equal to e power minus log y. So how to write this one? E power log of y inverse. So that is equal to 1 by y. So here what is the integrating factor is 1 by y. After finding the integrating factor, what is our next procedure? Multiply the given differential equation with 1 by y. Now multiply equation 1 with 1 by y. So if you multiplying with 1 by y, how to write the numerator? Y into 1 plus y by y into dx plus, again y get cancelled, that is x into dy is equal to 0. Now here these two are get cancelled, that is how to write 1 plus y into this is 1 plus y into dx plus x into dy is equal to 0 is a new differential equation which is of the form m1 into dx plus n1 into dy equal to 0, which is an exact differential equation. See here, dou m1 by dou y is 1 and dou n1 by dou x is also 1. So therefore, which is an exact. Equation 2 exact. So how to write the general solution? So general solution is integral m1 into dx plus integral terms free from x in n1 into dy is equal to c. So that implies integration of m1. So what are the terms of m1? 1 plus y into dx plus terms free from x. So there are no terms. So integral 0 into dy is equal to c. But first integration is performed with respect to 2x. Here this total 1 plus y is the constant, and what is integration of dx is x is equal to c. So therefore what is the general solution? 1 plus y into x is equal to c is the general solution of a given differential equation. In the next class, I will continue linear differential equations and equations reducible to linear, Bernoulli's equations and its applications. I will continue in the next session.